Hello students of class 8. Question number exercise 13D. Question number 12. A well with 10 meter inside diameter is dug 14 meter deep. Earth taken out of it is spread all around to a width of 5 meter to form an embankment. Find its height. So in here, first of all, we will have to draw a well. This will be the ground. Its inside diameter is given as 10 meter and its depth is given as 14 meter. Earth is taken out, okay, it is digging, earth is taken out from this well and it is spread, earth is taken out from this well and it is spread around this well to form an embankment. Okay, at the width of 5 meter. This width it is of 5 meter. Okay, so this embankment will also looks like a cylinder. This embankment, it also looks like a cylinder whose inside diameter and the inside diameter of this embankment and the inside diameter of the well, it will be same. Okay, so first of all we will take, let the radius and height of the well, be R1 and H1, and then let the radius and height of the embankment, this will be outer radius. Okay, let the outer radius and height of the embankment be R2 and H2. So next I will find volume of the well. Okay, volume of the well. It will be is equals to pi R1 square H1. Pi into R1, you see inside diameter of the well is 10 meters, so the radius will be 5 meter, 5 square into H. And this well, it is dug 14 meter deep, so 14 pi into 25 into 14 meter square. Okay, this is the volume of the well. Next I will have to find the volume of the embankment. Okay, volume of the embankment. Volume of the embankment, it will be is equals to pi R2 square H2 minus pi R1 square H1. Okay, pi R2 square meter square, pi R2 square H2 minus pi R1 square H1. Okay, pi R2 square, the outer radius, this is the outer radius. Okay, the outer radius, this will be is equals to 10 meter. Outer radius, it will be is equals to 10 meter, and height of this embankment I have to find, that is H2 I have to find. Okay, in here one more thing, pi R1 square, in here this will be not H1. Okay, this will be H2 only. Okay, pi R2 square H2 minus pi R1 square H2. Height of this embankment will remain same only. This will be H2. So from here I can take pi H2 common. I will get R2 square minus R1 square. Okay, pi H2, H it will remain same only. Okay, so volume of this embankment, okay, volume, you see the embankment, it looks like a cylinder. So volume of this embankment, I will have to find the volume of the outer cylinder minus volume of the inside cylinder. Okay, then I will get the volume of this embankment. Volume of the outer cylinder minus volume of the inside cylinder, then I will get the volume of this embankment. Okay, so volume of the outer cylinder, it will be pi r2 square h2. Okay, and then minus pi r1 square radius of the radius of the inside cylinder, radius of this inside cylinder, and radius of this inside cylinder, it will be same only. Volume, radius of the inside cylinder and radius of the well, it will be same only. Okay, radius of the inside cylinder, this embankment, it looks like a cylinder, so radius of the inside cylinder, it will be same as the radius of the well, it will be 5 meter. But again, this embankment is 5 meter width. Yes, the width of this embankment is 5 meters, so therefore the radius of this outside cylinder, it will be 10 meter. 5 plus 5, it will be 10 meter. So is equals to, in here, pi h2, this is a square minus b square formula, a plus b into a minus b is equals to pi h2. This is r2. R2 I have taken outer radius of the embankment, r2. So outer radius, it is 10. 10 plus r1, this is the inner radius of the embankment. Inner radius of the embankment and the radius of this well, it will be same, which is 5. Then again 10 minus 5. So in here is equals to, I will get pi h2 15 into 5. Okay, pi h2 15 into 5. So this one you can write it meter square. Okay, this is my volume of the embankment. Now you see, volume of this well will be equal to volume of the embankment. Okay, volume of the well, it will be equal to volume of the embankment. Because this embankment, how this embankment has been made? This embankment has been made by taking earth out of this well. Taking earth out of this well. So therefore the volume of this well will be equals to volume of this embankment. Okay, so therefore after that, by question I can write volume of the well equal to volume of the embankment. You write it, volume of the well equal to volume of the embankment. Volume of the well, it is this much, pi into 25 into 14 is equal to volume of the embankment. It will be pi h2 into 15 into 5. Okay, pi h2 into 15 into 5. In a pi cut, 25 into 14 by 15 into 5 is equals to h2. Okay, so 5 5s are 25, 5 3s are 15 is equals to 14 by 3 h2. This one, 14 by 3 is equals to h2. Okay, if you want to write this in decimal form, so 14 4 3 4s are 12, 2 2, then 0.0, 3 6 are 18, again 2, so 3.6 meter you can write. Again it will 3.66 meter is equal to 4 point is equals to 4.66 meter is equals to h2. Okay, 4.66 meter is equal to h2. So let me explain one more time what is going on here. First of all, the question is saying that a well it is dug. Okay, well it is dug, and the earth is taken out and spread around this well. Okay, and it is spread around this well in such a way that it will take the form of a cylinder. Okay, it has an embankment has been made. Okay, embankment, so that somebody will not accidentally fall down in this well. So therefore an embankment is from the earth taken out of this well. So therefore the volume of this cylinder will be equal to volume of the embankment. First of all, volume of the well will be equal to volume of the embankment. Okay, so first of all, I will have to find the volume of this well. Okay, I will let the radius and height of the well be r1 and h1, and then let the outer radius and height, as this embankment looks like a cylinder, so the outer radius, okay, because the inner radius of the embankment and the inner radius of the cylinder, it will be same. So therefore r1 only I can take. Okay, inner radius of the embankment, I can take r1 only. Okay, So therefore, volume of the embankment, volume of the embankment, it will be is equals to volume of the outer cylinder, minus volume of the inner cylinder. I will get the volume of this embankment. Okay, now volume of the outer cylinder, it will be is equal to pi r2 square h2, and volume of the inner cylinder will be pi r1 square h2. Height will be same only. This is height of the embankment. Pi r2 square h2 minus pi r1 square h2. Okay. So therefore from here pi h2 I can take common. So I will get r2 square minus r1 square. Okay, this you solve it, you will get 4.66 meter. Okay, 4.66 meter. Let's check the back answer one time. Exercise 13D. Exercise 13D. Exercise 13D. You see 4.66 meter. Okay, 4.66 meter. Next, in our next video, we will discuss question number 13. Okay, a cylindrical tube open at both ends is made of metal. The inner diameter of the tube is 11.2 centimeter and its length is 21 centimeter. The metal everywhere is 0.4 meter. Calculate the volume of the metal correct to 1 decimal place. So in here you see a cylindrical tube, okay, open at both ends. These questions you can try to do by yourself. It is not so much hard. So first of all, you see question number 13, it is saying that a cylindrical tube open at both ends. Okay, this is a cylindrical tube. This is a cylindrical tube. It is open at both ends. Okay, it is open at both ends. This is a cylindrical tube. This is a cylindrical tube open at both ends. Okay, this is a cylindrical tube open at both ends. Then the inner diameter of the tube, it is equals to 11.2 centimeter and its length is 21 centimeter. Its length it is given as 21 centimeter. The metal everywhere is 0.4 centimeter thick. The metal everywhere it is the metal everywhere it is 0.4 centimeter thick. Calculate the volume of the metal correct to 1 decimal place. Okay, so in here first of all I will have to take let the radius of the outer cylinder be r1. Okay, and let the radius of the inner cylinder be r2. Okay, then the radius of volume of the metal. Okay, volume of the metal, it will be is equals to volume of the outer cylinder minus volume of the inner cylinder. Okay, volume of the outer cylinder, it will be pi r1 square h. Height will be same only, so h only you can take. Okay, minus pi r2 square h. Okay, pi r2 square h. So is equals to, from here pi h you can take common. I will get r1 square minus r2 square. R1 square minus R2 square. Now you see is equals to pi h into R1. R1 I have taken, it is the radius of the outer cylinder. So radius of the outer cylinder, it will be what? Diameter of the inner cylinder, it is this much, 11.2. Yes, so 11.2, if you divide it by 2, how much you will get? 2 5s are 10, 1, 2, 2 6 are, so 5.6 meter. This is the inner radius of the cylinder. Okay, and the outer radius of the cylinder with this inner radius, if you add 0.4, 10, 6. Yes, if you add 0.4, you will get 6 meter. So therefore the outer radius will be 6 meter. 6 square minus r2 square, which is the inner radius, which is inner radius is 5.6. So 5.6 the whole square. Okay, so is equals to pi value you can take 22 by 7 into height it is given 21. This will be 36 minus 5.6 into 5.6. 6 6 are 36, 5 6 are 30, 33, 5 6 are 30, 5 5 are 25, 28, 6 3 this one 9 10 11 3. So I will get 31.36, 36.00 minus 31.36, I will get 10,49654. This will be 0. So is equals to 22 by 7 into 21 into 4.64. 7 threes are, so 22 into 3 into 4.64. If you do, you will get the answer. Okay, let's calculate 22 into 3 into 4.6, 22 into 3 into 4.64 is equals to, you will get, this is the answer, is equals to, you will get 306.24 meter square. Okay, 306.24 meter square. This will be the answer. Next, it is a cylindrical bucket, 42 centimeter in diameter and 50 centimeter high, is full of water. The water is emptied into a rectangular tank 66 centimeter long and 21 centimeter wide. Find the height of the water level in the tank. Okay, so a cylindrical bucket 42 centimeter in diameter and 50 centimeter high. Okay, the water is emptied. So first of all, you empty into a rectangular tank long and 21. Find the height of the water in the tank. So first of all, you will write volume of the cylinder. Okay, volume of the cylinder, it will be is equals to pi r square h. Okay, pi r square h. Volume of the cylinder, it will be is equals to pi r square h. Okay, pi r square h. Okay, so in her inner diameter is 42 centimeters, so radius will be 42 by 2. Okay, it will become 21, and then height is given as 50. Okay, this is very easy there. Question number 14. One in here saying that one cylindrical bucket 42 centimeter in diameter. Okay, cylindrical bucket 42 centimeter in diameter and 50 centimeter high is full of water. So first of all, I will find volume of the bucket. Okay, volume of the bucket, it will be is equals to pi r square h, equal to 22 by 7 into radius will be 42 by 2 to the whole square, and height will be 50. Okay, so 22 by 7 into 21 square into 50. So I will get 22 by 7 into, this will be 21 into 21 into 50. 7 3s are 21. 22 into 3 into 21 into 50. Okay, so this one I will have to calculate it. Okay, it will become centimeter square. Next, again I will have to find volume of the rectangular tank. Okay, volume of the rectangular tank. Volume of the rectangular tank, it will be is equals to length into breadth into height. Okay, length into breadth into height is equals to length, it is given as 66, breadth it is given as 21. I have to find the height. Yes, height of the water means height of the rectangular tank only. Okay, so now I can write by question I can write volume of the bucket is equals to volume of the rectangular tank. Okay, volume of the cylindrical bucket is equal to volume of the rectangular tank. You write volume of the bucket equal to volume of the rectangular tank. Volume of the bucket, it is this much, 22 into 3 into 21 into 50 is equals to volume of the rectangular tank, it is this much, 66 into 21 into height. Okay, so therefore 22 into 3 into 21 into 50 by 66 into 21 is equals to height. Okay, now let's calculate the height. 3 22s are 66, 22 22 gone, 21 21 gone, 50 centimeter is equals to height. Okay, therefore the height of the therefore I can say that the height of the rectangular tank, yes, height of the rectangular tank or height of the water level in the tank, whatever you write, it is equals to how much? 50 centimeter. Let's check the back answer. Exercise 13D, question number 14. Exercise 13D, question number 14, you say 50 centimeter. And question number 13, the back answer, it is not matching with my answer. No problem in here, I think back answer, it is wrong there. Okay, I hope you have understood. Thank you.